Alright, let's take a look at this question. Now, Mr. Lim's student went for a hike in the jungle and they decided to use their teacher's method to collect drinkable water as shown below. And this question looks a bit like this old question that we discussed during one of the Q&A sessions. So, of course, typically in such questions, we talk about the rate of evaporation from this water outside the container. And we know that there's this slanted slope that was created by putting something heavy in the middle. So whatever water that is evaporated, the water vapor, okay, and that water can then condense on the cooler surface of this plastic sheet, slide down the middle, and then drip here. Now, of course, we should not allow the past experiences to influence our current answer because there could be fine, minute changes that could make it different. Let's come back to this one. So, okay, this is similar. There was a plastic sheet. There's a rock in the middle. There's a stone here to hold on to this. And what's different is I notice there's a straw. So this is a difference. I wonder what the straw for. There are some plants here. There's another difference. So all these differences usually would mean that these are some clues for you to see how this thing works. Container and wet soil. So now we don't have water, but we have wet soil. So wet soil, of course, still equate to the presence of moisture, water that can evaporate. So how can the student collect more water? Now, of course, to collect more water, we have just a few ideas. The main concepts for collecting more water, right, will be increasing the rate of evaporation. Right, if you can increase the rate of evaporation, then there will be more water vapor that can condense on the under side of the plastic sheet and then drip down the middle, flow to the middle and drip into the container. You can increase the rate of condensation. Usually we do this by increasing the temperature difference between the interior temperature here, like the water vapor temperature, and the surface. For example, put ice on top and so on and so forth. Of course, it is in a jungle, so reasonably speaking, there should be no ice for the person to put on top of the plastic sheet. Alright. So these are the two main ideas. There's one more which should be the and this is related to the first one, and that will be to increase the exposed surface area of the we should increase the rate of evaporation. Alright. Now, of course, increasing the temperature, and of course, another way is to increase the temperature of the surroundings. These are several ways we can. Now, of course, wind is the last condition where we can increase the rate of evaporation. But in this case here, wind does not work because this is an enclosed environment. So wind are not supposed to, blow inside to increase the rate of evaporation. Right. So I think the first two ideas should work. All right. So I think this is easiest. I suppose this answer is fine. In other words, when a person is doing this, when Mr. Lim's student is doing this should be done under the sun. Alright? Now, there are other things that can be done also. If you want more water, we need more water to evaporate. Currently, there are some plants here, some wet soil here. Alright? Now, how can this work? Now, of course, if I want to have more water collected here, I need to have more sources of water that can evaporate, right? Now, there are some plants here, which means that there would be some evaporation from their stomata. Now, since it's a jungle, if I can place some more leaves inside the dugout area, I put some leaves, and the leaves are, it contains moisture as well. Then the evaporation from those leaves that I picked up, of course, don't pick up dry leaves, okay? Pluck some leaves from the tree, and that can also increase the amount of water that can evaporate. So I can increase that as well. Right, so I can maybe increase the number of leaves, and the idea is more sources of water equals to there will be more water that can evaporate. So I think this will work. And explanation, of course, if under the sun, now you're talking about this increasing temperature difference idea. So the water in a wet soil and plants gain heat faster and have a high rate of evaporation. So more water vapor. Okay, so let's give the mark allocation for that. The first one mark will be for your suggestion. Alright, you get this. Second one mark is for your explanation part. Let's take a look at this. Explanation will be, alright, gain heat, evaporate, yes, higher rate of evaporation. More water vapor can then lose heat to the plastic sheet, condense to form water droplets which fall into the container. That's fine. Alright. Now first, I'm sure you can see any of the other ideas here can work as well. For example, I'll try not to use this. If I use exposed surface area, that means I have to maybe change the container into a smaller container so I can put in more leaves, which I don't think I want to do it here. Usually try not to change containers. I can increase number of leaves. An explanation for this would be then there will be more sources of water, so there could be more water that can evaporate to have more water vapor that can condense and drip into the middle. Imagine if I only have one leaf here or one grass here, then that will not be enough source of water. Okay, now for another question. Mei Ling sets up a toy house as shown in the diagram. She wants the two bulbs to be lit at the same time and of equal brightness. So equal brightness, correct. I'll give you a clue. This is something about them being the bulbs in parallel. At the same time will tell me that there will be one switch, alright, that controls both bulbs. Here's the idea of at the same time I press one switch and then both are lit at the same time. That's why I see one switch here. Complete the circuit diagram so it will as described. Let's take a look. So let's say current flow through here. Alright, current flow through here. Correct. So current flow is correct. Let's take a look at connection here. That is also correct. Metal tip and casing. Metal tip and casing. Alright, no problem. So this is correct. You get your mark here. See the arrangement of the bulbs in your drawing. So parallel. Okay, fine. In this case, you can just write one word parallel because the question already said arrangement of the bulbs. You know how I feel about just using one word answer? Because just parallel could be parallel to what? But since the question already said arrangement of the bulbs, it's fine to say parallel arrangement of the bulbs. Alright, so that's all. So good job. All the best to your preparation for your exams.